Section 3.4, Graphs of Polynomial Functions. In this section, we're going to learn how to recognize characteristics of graphs of polynomial functions, find zeros by factoring, identify zeros and their multiplicities, determine the end behavior of polynomial functions, understand the relationship between degree and turning points, and finally use the intermediate value theorem. Some of this will be a little familiar because we just did quadratic functions, and quadratic functions are polynomial functions of degree 2. So in this section, we kind of extend that to polynomial functions of degree greater than 2, but some of this will sound familiar. So the graphs of polynomials of degree 2 or more are smooth, continuous functions. So smooth and continuous, let's talk about what those mean. And I have 4 examples here that are in your textbook. So this first example is the graph of a polynomial. This graph is smooth and continuous. Smooth meaning it doesn't have any breaks in it, doesn't have any sharp corners, it's very smooth. And continuous means that I could sketch this graph without lifting my pen. There's no breaks in it. So this is an example of a polynomial function. The second function you may recognize is the absolute value function, and the absolute value function is not a polynomial. Why? It has a sharp corner. It's not smooth. And so that's how we would recognize that that is not the graph of a polynomial. Before I write the answer to this one, take a look at this graph. What do you think? Do you think that's a polynomial? Yes or no? Okay, well, hopefully you thought yes. It's a smooth, continuous curve. But this next one, notice it's smooth, but if I were going to draw it, if I did this first piece, I would have to lift my pencil in order to get to the second piece. So this is not continuous. So the graphs on the left are of polynomials, and the graphs on the right are not polynomials. Excuse me. Finding the x and y intercepts of polynomials. Excuse me. To find the x and y intercept of a polynomial, you can factor or you can use technology. So let's find the intercepts of f of x is equal to x to the 6th. One moment. I'm really sorry. It's a real pain to stop the recording and start it again, so I hope you don't mind if I just left my coughing in there. I apologize. So find the intercepts of x to the 6th minus 3x to the 4th plus 2x squared. All right. So the y-intercept is always very easy to find. The y-intercept is just f of 0. So f of 0 would be equal to 0 minus 0 plus 0. Oh, well, that's pretty easy. The y-intercept is 0. Now the x-intercepts are a little harder. For the x-intercepts, we have to either factor or use technology. So for these first ones, I'm just going to review factoring with you. So x to the 6th minus 3x to the 4th plus 2x squared. The first thing we're always going to look for in factoring is a greatest common factor. So the greatest common factor here, let me just fix this last term. The greatest common factor here, they all have x's, and the greatest common factor would be x to the 2nd. So that would be x to the 2nd times x to the 4th minus 3x squared plus 2. And now, when we look at this trinomial here, we notice that it looks factorable also. So we have x to the 2nd. If we were to factor this one, this would factor as x squared minus 2 and x squared minus 1. We could check that for a moment if we weren't sure. Negative 2x squared minus 1x squared, so that does give us negative 3x squared. And the signs are correct, so this is how we would factor. And one last thing to remind you of, because you would think, oh, we're finally done. This piece here is the difference of squares. and we can factor the difference of squares. So the final answer so far would be x squared. X squared minus 2 is not the difference of squares, but x squared minus 1 can be factored as x plus 1, x minus 1. Now, why were we doing all this factoring? So we could find the x-intercepts. So what we do to find the x-intercepts is we take each one of these 4 factors and we set them equal to 0 and solve. So for the first one, x squared is equal to 0. I know that x is equal to 0. For the second one, x squared minus 2 is equal to 0. That tells me x squared is equal to 2. To solve that, I'm going to take the square root, remembering that it could be positive or negative. So x is equal to the positive square root of 2, and x is equal to the negative square root of 2. For the third one, x plus 1 is equal to 0, so x is equal to negative 1. And for the last factor, x minus 1 is equal to 0, so x is equal to positive 1. So notice, when we finish, let's just count them all up. We have 1, 2, 3, 4. We found 5 roots, 5 x-intercepts. Now you may wonder, how many are we expecting? Well, if you look at the degree of the leading term, the degree of the leading term tells you the maximum number of roots that you'll find. So at most we would find 6 roots, and we found 5. All right, we'll talk a little bit about how you know how many of each root you're going to have in a little while. Let's try this next one. Find the intercepts of x squared minus 5. Let me just change this for a moment. We're going to change this to x cubed. Find the intercepts of x cubed minus 5x squared minus x plus 5. So the y-intercept is easy. The y-intercept, we're just going to substitute 0 in for x. That would give us 0 minus 0 minus 0 plus 5. The y-intercept is 5. So this graph is going to pass through the point 0, 5. It's the x-intercepts that are a little more work that we want to practice right now. So we're going to try to factor x cubed minus 5x squared minus x plus 5. And so last time I reviewed greatest common factor with you. This time I'd like to review how to factor when you have 4 terms and not a greatest common factor for all 4, but in pairs. So for example, these two have a greatest common factor of x squared times x minus 5. Minus, and these do not seem to have a common factor, but if we factored out a 1, we could factor that as negative 1 times x minus 5. And you might wonder, well, why am I doing that? Because now these two terms have a common factor of x minus 5, and it's x minus 5 times x squared minus 1. Again, difference of squares, x minus 5 times, this was x plus 1, x minus 1. Now, we don't stop just because we've done the factoring. What we need to do is we need to take these factors, and there's 1, 2, 3 of them, set them equal to 0, and find the intercepts. So I'm going to let you do that. Okay, so go ahead and just like the last example, take each of those factors and set them equal to 0 and see if you can find the 3 x-intercepts. Let's take a look at another example. Find the intercepts of x plus 3 squared times 3x minus 2. So this is already in factored form, which is really convenient. So we just have to set each factor equal to 0 and solve. So we have x plus 3 is equal to 0. If we solve that, we have a root at x is equal to negative 3. 3x minus 2 is equal to 0. If you take a moment and solve that, you come up with x is equal to 2/3. Now, see how this factor has a square in it? What we say is that this is a root of multiplicity multiplicity, so that might be a new word for us, multiplicity 2, meaning that it occurs 2 times. If I were to take that factor and expand it, x plus 3 times x plus 3. So if I were to solve each one of those factors equal to 0, I would get negative 3 2 times. So that's why we say it's a root of multiplicity 2. Back here in this first example that we did, see how that was x squared is equal to 0? In other words, x times x is equal to 0. We could say that 0 was also a root of multiplicity 2. Okay. Now, a lot of times we can't factor, we don't feel like factoring, we don't want to factor, okay, variety of reasons. And so you can use technology to find intercepts. I can't do that on my iPad very well, so I'm going to do this one in class. But I have this placeholder in your notes, and I'm going to kick off our classwork time on this topic while I show you on a graphing calculator. I can do it on my computer, I just can't do it on my iPad, so I'm going to do this with you in class. But I want to leave the notes here. Just know that you can use technology. You can use a graphing calculator to find roots. Most of you probably already know how to do this, but I'm going to review that during class. Okay.